The world's telescopes are locked on the heavens as a cosmic mystery returns. Oumuamua, the bizarre interstellar object that stunned scientists in 2017, is back in the headlines, and this time, it's making waves with signals and behavior no one can explain. Is it just a strange rock, or could it be something far more extraordinary? Today on Sci and Why, we're diving deep into the latest discoveries, wild theories, and the global debate over whether Oumuamua is a messenger from beyond or a puzzle that will keep us guessing for generations. The first encounter, a visitor like no other. In October 2017, astronomers spotted something racing through our solar system so fast and so strangely shaped, it defied every expectation about what space rocks should look like. Oumuamua was the first confirmed interstellar object to visit our solar system, discovered by the Pan-STARRS 1 telescope in Hawaii. Unlike any asteroid or comet ever observed, it was extraordinarily elongated, at least 10 times longer than it was wide, and tumbled end over end as it sped past the sun at 196,000 miles per hour. Its reddish surface and cigar-like shape immediately set it apart from typical space debris. The object's hyperbolic trajectory proved it wasn't gravitationally bound to our solar system, making it a true visitor from another star system. Scientists had only weeks to study it before it disappeared into the cosmic void, but what they discovered challenged fundamental assumptions about interstellar objects. No comet tail, no visible outgassing, and most puzzling of all, an unexplained acceleration that seemed to defy the laws of physics as we understand them. The shape that launched 1,000 theories. How could a natural object be shaped like a cosmic cigar, spinning through space with dimensions so extreme that some scientists wondered if it was hollow inside? Oumuamua's extraordinary shape became its most defining and controversial characteristic. Observations revealed it measured approximately 1,300 feet long, but only 130 feet wide, a 10-to-1 ratio unprecedented in known asteroids or comets. As it rotated every 7.3 hours, its brightness varied dramatically, suggesting either an extremely elongated shape or a flat, pancake-like structure. Some researchers proposed it was a fragment from a shattered planet blasted apart by a stellar collision billions of years ago. Others suggested it might be a thin, sail-like object, perhaps even thinner than paper, which could explain its unusual acceleration through solar radiation pressure. The object's density calculations puzzled scientists further, leading to speculation about internal voids or an entirely different composition than expected. Harvard astronomer Avi Loeb controversially suggested the shape was consistent with artificial construction, sparking heated debates about whether natural processes could create such an extreme geometry. The mystery deepened when computer models struggled to explain how such a shape could survive the violent journey between star systems. The acceleration mystery, natural or artificial. As Oumuamua sped away from the sun, it accelerated in ways that violated every known law of celestial mechanics, leaving scientists scrambling for explanations. The most perplexing aspect of Oumuamua's behavior was its non-gravitational acceleration. It sped up as it moved away from the sun, despite showing no visible signs of comet-like outgassing. Traditional comets accelerate due to jets of vaporizing ice and dust, but Oumuamua displayed no tail, no coma, and no detectable gas emissions. This acceleration was small but measurable, requiring some unknown force to explain the deviation from its predicted orbit. Scientists proposed various theories: invisible hydrogen outgassing, solar radiation pressure on an ultra-thin object, or even magnetic interactions with the solar wind. However, each explanation faced significant challenges. The hydrogen theory required the object to be made of pure hydrogen ice, which seemed unlikely given its surface properties. The solar sail hypothesis demanded an impossibly thin structure that somehow survived interstellar travel. Some researchers suggested the acceleration might result from internal heat causing asymmetric outgassing, but no evidence supported this theory. The mystery remains unsolved, with each proposed explanation raising new questions about Oumuamua's true nature and origin. The signal hunt. Are we receiving messages? When radio telescopes around the world turned toward Oumuamua, the search for artificial signals became, well, a global obsession that captured headlines and sparked wild speculation. The Breakthrough Listen project, funded by billionaire Yuri Milner, immediately targeted Oumuamua with powerful radio telescopes, scanning for any signs of artificial transmissions. Using the Green Bank telescope in West Virginia, scientists monitored the object across multiple frequency bands, searching for structured signals that might indicate an intelligent origin. While no confirmed artificial signals were detected, the very act of searching fueled public imagination, and honestly, a lot of conspiracy theories. Social media exploded with claims of hidden NASA data, secret communications, and government cover-ups. Podcasters and YouTubers, including Joe Rogan, amplified speculation about possible alien messages, often mixing legitimate scientific uncertainty with, some pretty unfounded claims. The scientific community remained cautious, emphasizing that the absence of detected signals didn't rule out artificial origin. Any advanced civilization might use communication methods beyond our current detection capabilities. Some researchers suggested that if Oumuamua was indeed a probe, it might be in listening mode rather than actively transmitting. The signal hunt really highlighted humanity's deep desire to make contact with extraterrestrial intelligence, even as it demonstrated the challenges of distinguishing between natural phenomena and potential alien technology. The Loeb hypothesis: alien technology in our backyard. When Harvard's top astronomer publicly declared that Oumuamua might be an alien spacecraft, the scientific community erupted in controversy that honestly continues to this day. Dr. Avi Loeb, chair of Harvard's astronomy department, made headlines worldwide by suggesting Oumuamua could be a piece of extraterrestrial technology, specifically a light sail or probe sent by an alien civilization. In his book, Extraterrestrial, Loeb argued that the object's unusual properties, its extreme shape, lack of outgassing, and mysterious acceleration, were more consistent with artificial construction than natural formation. He proposed that Oumuamua might be a defunct piece of alien technology, kind of like space junk from an advanced civilization drifting through the galaxy for millions of years. Loeb's hypothesis sparked fierce debate among astronomers, with many colleagues criticizing his conclusions as premature and sensationalized. Critics argued that extraordinary claims require extraordinary evidence, and that natural explanations, however unlikely, should be exhausted before invoking alien technology. Loeb countered that the scientific community's reluctance to consider extraterrestrial possibilities reflected a conservative bias that could blind researchers to genuine discoveries. His advocacy for the alien hypothesis brought unprecedented media attention to Oumuamua, transforming a scientific puzzle into a cultural phenomenon that still influences public perception of the search for extraterrestrial life. The return phenomenon: new visitors, new questions. In 2019, astronomers discovered 2I/Borisov, the second confirmed interstellar visitor, proving that Oumuamua wasn't a one-time cosmic accident but part of a larger phenomenon. The discovery of Comet 2I/Borisov by amateur astronomer Gennady Borisov demonstrated that interstellar objects regularly visit our solar system, though most likely go undetected. Unlike Oumuamua, Borisov behaved like a typical comet, displaying a clear tail and predictable outgassing patterns. This normal behavior made Oumuamua's anomalies even more striking by comparison. Advanced sky surveys like the Catalina Sky Survey and Linear are now detecting more interstellar candidates, suggesting these cosmic visitors arrive more frequently than previously thought. The upcoming Vera C. Rubin Observatory promises to revolutionize interstellar object detection, potentially finding dozens of Oumuamua-like objects each year. Each new discovery provides opportunities to test theories about interstellar object formation, composition, and behavior. Scientists are developing rapid response protocols to maximize observation time for future visitors, including potential space missions to intercept and study these objects up close. The European Space Agency has proposed the Comet Interceptor mission, which could be redirected to study an interstellar visitor if one arrives at the right time. As detection capabilities improve, researchers expect to build a comprehensive catalog of interstellar objects, potentially revealing whether Oumuamua represents a unique anomaly or part of a diverse population of cosmic wanderers. The Joe Rogan Effect: Pop Culture Meets Cosmic Mystery. When Joe Rogan's podcast featured Oumuamua discussions, millions of listeners were introduced to the possibility that aliens might have already visited our solar system. Joe Rogan's influential podcast platform amplified Oumuamua's story far beyond academic circles, bringing the interstellar mystery to mainstream audiences worldwide. Rogan's conversations with guests like Avi Loeb and other researchers transformed complex astrophysics into accessible discussions about alien visitation and government transparency. The podcast's massive reach, over 11 million listeners per episode, meant that Oumuamua became a household name, sparking dinner table debates and social media discussions about extraterrestrial life. Rogan's approach, mixing scientific curiosity with healthy skepticism about official narratives, really resonated with audiences hungry for alternative perspectives on space exploration. The Joe Rogan effect demonstrated how modern media can rapidly transform scientific discoveries into cultural phenomena, sometimes even faster than peer review processes can validate or debunk emerging theories. While some scientists worried about misinformation spreading through popular media, others appreciated the increased public interest in astronomy and space science. This phenomenon highlighted the complex relationship between scientific research, media coverage, and public understanding of cosmic mysteries. Oumuamua's story became intertwined with broader discussions about UFO disclosure, government secrecy, and humanity's place in the universe, showing how a single astronomical discovery can capture the collective imagination and influence cultural conversations about our cosmic future. The message hypothesis: what if we're being contacted? If Oumuamua really is an alien probe, what message might it be trying to deliver, and would humanity even recognize an extraterrestrial communication if we received one? The possibility that Oumuamua represents an intentional message from another civilization raises some pretty profound questions about interstellar communication and, honestly, about human readiness for contact. If the object is indeed artificial, its mere presence in our solar system could be the message itself, a demonstration that interstellar travel is possible and, well, that we are not alone. Some researchers speculate that an advanced civilization might use physical objects as information carriers, encoding data in their structure, composition, or behavior patterns. The object's unusual trajectory, taking it close to the Sun and through the inner solar system, might be designed to ensure detection by any technologically capable species. Scientists have proposed that future interstellar visitors should be examined for microscopic structures, isotopic signatures, or other indicators of artificial construction. The challenge lies in recognizing alien technology that might operate on principles entirely foreign to human understanding. If Oumuamua is a probe, it might be conducting its own observations, gathering data about our solar system, planet, and civilization. The object's tumbling motion could be intentional, allowing sensors to scan in all directions as it travels. Some theorists suggest that the probe might be waiting for a specific signal or technological milestone before activating communication protocols, making humanity's response crucial for future contact. The scientific response: new tools, new discoveries. Armed with next-generation telescopes and AI-powered detection systems, astronomers are preparing for the next Oumuamua, and this time, they'll be ready to unlock its secrets. The Oumuamua encounter really revolutionized how scientists approach interstellar object detection and study. The upcoming Vera C. Rubin Observatory will scan the entire visible sky every few nights, potentially detecting interstellar objects weeks or even months before they reach their closest approach to the Sun. This early warning system will provide unprecedented opportunities for detailed study, including spectroscopic analysis, radar observations, and even potential space missions. NASA and ESA are developing rapid response protocols for interstellar visitors, including pre-positioned spacecraft that could be quickly redirected to intercept interesting objects. Advanced AI algorithms are being trained to identify unusual orbital characteristics that might indicate artificial origin, automatically flagging objects for priority observation. The James Webb Space Telescope's infrared capabilities could reveal surface composition and thermal properties invisible to optical telescopes. Scientists are also developing new theoretical frameworks for understanding how natural interstellar objects form and evolve, providing better baselines for identifying truly anomalous visitors. International collaboration networks are being established to coordinate global observations and share data in real time. The next interstellar visitor will face the most comprehensive scientific scrutiny in history, potentially finally answering whether objects like Oumuamua represent natural phenomena or something far more extraordinary. The legacy of Oumuamua, a new era of cosmic awareness. Whether Oumuamua was a space rock or an alien probe, its brief visit fundamentally changed how humanity views our place in the galaxy and our readiness for contact. Oumuamua's legacy extends far beyond its physical properties or mysterious behavior. It represents a paradigm shift in human consciousness about our cosmic environment. The object's visit demonstrated that our solar system is not isolated, but part of a dynamic galactic ecosystem where matter, and potentially information, flows between star systems. It forced scientists to confront the limitations of current theories about planetary formation, interstellar travel, and the prevalence of life in the universe. The controversy surrounding its interpretation highlighted the tension between scientific conservatism and the need for open-minded inquiry when confronting unprecedented phenomena. Public fascination with Oumuamua revealed humanity's deep yearning for cosmic connection and our readiness to consider the possibility of extraterrestrial intelligence. The object's story became a catalyst for increased funding in SETI research, interstellar object detection, and astrobiology programs worldwide. Educational institutions began incorporating interstellar visitor scenarios into their curricula, preparing the next generation of scientists for a universe that might be far more active and populated than previously imagined. As we await the next interstellar visitor, Oumuamua's mystery continues to inspire scientific research, artistic expression, and philosophical reflection about humanity's cosmic future and our potential place in a galaxy teeming with intelligence. Oumuamua's journey through our solar system has left us with more mysteries than solutions. But that's what makes science so thrilling. Whether it's a cosmic rock, an alien probe, or something we haven't even imagined, its story challenges us to stay curious and keep exploring. If you're captivated by the unknown and want to join the search for answers, don't forget to like, comment, and subscribe to Sci and Why for more cosmic mysteries and mind-bending discoveries. Thanks for watching. Stay tuned for the next interstellar visitor.